What is voltage? Defining electric pressure. The third core question is, what is voltage, and why is it essential to the movement of electrical energy? In simple terms, voltage is the electric force or pressure that pushes electrons through a conductor. The official term. Scientifically, voltage is the measure of potential difference between 2 points in an electric circuit. It represents the energy required to move a unit of electric charge between those 2 points. Measured in volts. Voltage is measured in volts, $V, named after the Italian physicist Alessandro Volta, who invented the first chemical battery. 1 volt is equal to 1 joule of energy per coulomb of electric charge. The water analogy. To help visualize this concept, we often use the water analogy. Think of electricity flowing through a wire like water flowing through a pipe. Pressure in the pipe. In this analogy, the voltage is like the water pressure in a pipe. The higher the pressure, the harder the water, or electrons, are pushed, and the faster the flow can be. A necessary difference. You only get a flow of water when there is a difference in pressure, for example, a water tower higher than your tap. Similarly, electricity only flows when there is a potential difference, voltage, between 2 points. The role of the power source. The job of a power source, like a battery or a generator, is to create and maintain this high potential difference. It does the work to keep the electric pressure high at one end of the circuit. Electrons and energy. This pressure gives energy to the electrons. When an electron moves from the high pressure, negative, side to the low pressure, positive, side, it releases that potential energy, which we use to power things like lights and motors. Why voltage matters? Voltage is crucial because it determines how much energy each electron carries. A high voltage transmission line means each electron is carrying a tremendous amount of energy, allowing power to be transmitted efficiently over long distances. High versus low voltage. In everyday use, we deal with low voltages, like 1.5 V from a battery, to medium voltages, like 120 V or 240 V household outlets, and very high voltages, hundreds of thousands of volts on the power grid. Understanding amperage. It's important not to confuse voltage, the pressure, with current or amperage, the volume or flow rate of the electrons. Both are necessary to deliver power. Final pressure point. Ultimately, voltage is the driving force, the electrical push, without which electrons would simply sit still, and the electrical circuit would remain lifeless.